Hey class, welcome back to Chapter 3, Linear Relationships. Today we'll be looking at Exercise 3b, solving linear equations with the unknown on both sides. So previously we looked at solving equations where there was only a variable on one side. This time we'll have perhaps x or y or whatever letter we might be dealing with on both sides of the equation. Okay, so to do that, we first want to get all of the variables on one side of the equation, and then we continue to perform our inverse operations until it's isolated, just as we would normally if there was only one pronumeral present on one side of the equation. Okay. A little side note, literal equations are those that have multiple pronumerals in them. Okay, so two or more different pronumerals. Let's try some examples, shall we? So in this first example, we've got 4 take x equals 2x minus 2. Now my recommendation is always to move the smaller coefficient for x across. Okay, so in this case we've got negative x and positive 2x. So the negative x is the smaller one. The opposite of take x is plus x, and in doing that to both sides we move it across, which leaves us with 4 equals 3x minus 2. Now it does not matter which side of the equal sign or which side of the equation your pronumeral ends up on, you'll get the same answer either way. Okay. We now continue to work back for x. So I'm going to reverse the minus 2 by adding 2 to both sides, leaving us with 6 equals 3x, and then we divide both sides by 3, of course, to leave us with x equals 2 or 2 equals x. Okay. So our first step is going to be, again, in this one, we want to get all of the pronumerals on both sides. Now, in this particular equation, we could get rid of the divide by 3 first before moving it across, but I can see from this that I'm going to get thirds in my answer, which is just very uncomfortable at the moment. So let's start by expanding the brackets, which gives us 3x minus 27 equals 8x plus 1. Before we move the x across. So again, I look at my two x variables. All right, I've got 3x and 8x. In this case, again, 3x on the left-hand side is going to be my smaller coefficient. So I'm going to move that one across. The reason I picked the smaller one is to try and avoid negatives. Okay, it's very easy to lose negative coefficients later. So that's now gone, leaving us with negative 27 equals 5x plus 1. All right, and then of course we're going to subtract the 1 from both sides, which cancels that out, leaving us with negative 28. Remember that a negative subtracting more becomes more negative, equals 5x. And then we'll divide both sides by 5. Okay, leaving us with x equals, if you would like to convert it to a decimal, we get negative 5.6. Okay, and because this is a nice terminating decimal, negative 28 divided by 5, I can write it as a nice negative decimal answer. Okay. Last one now. This is what we were talking about, a literal equation. Okay. So here I don't just have x, I have y and v also. All right. Now in this case we could expand the brackets first, but because everything else is letters and it's not going to give me awkward fractions like thirds would, okay, we can just go straight to dividing both sides, in this case by 2, all right, which gets rid of that. I now have x plus y left on this side equals v over 2. So instead of handling with whole numbers, instead of having, say, 6 divided by 2 equals 3, we just write it as a fraction, v over 2, because we don't know what y or v are. We may eventually find out what they are, or we may be told to substitute certain things for those letters as well and then solve for x. But if we rearrange x for its own equation anyway, we can do that substitution step after for any number of sets of variables. Okay. Finally, we need to get x on its own, so we're going to subtract y from both sides, which leaves us with x, as we want, equals v over 2 minus y. You could also write this, these mean the same thing, as v minus 2y over 2 if you wanted to write it as one big fraction. Okay, these would both be correct. All right, you can either write the y outside of the fraction or within it. And that concludes today's lesson, guys. So as always, if you have any questions, send them through, but otherwise, good luck with the work and I'll speak to you all very soon.